In this lesson, we are calculating the volume of a cylinder. Now, a cylinder is just a prism, a 3D shape with an even cross-section all the way through. But this time, it's a prism with a circular cross-section. Now, we can see that that circle, if we sliced it all the way across, we would keep getting that same circle. This one's not a cylinder, but it's showing that idea of a cross-section, that even though this is an irregular shape, if we sliced it in the same way, we would keep getting that same slice shape over and over. Now, we can use the exact same Prism rule, which is volume is equal to area of the cross-section multiplied by the height of the 3D shape. So we've done it with rectangular prisms and triangular prisms. Now we're going to work with the same formula with a cylinder, because it's just going to use a circle instead as the area of the cross-section. Right, let's find the volume of these cylinders correct to 2 decimal places. So we have our nice rule to start with, volume equals area times by height. We are finding the area of our cross-section, and we can recall that area of a circle is pi r squared. So that's what we're going to substitute in. Pi r squared times capital H for our 3D height. We know that pi doesn't change, so pi times our radius, which is equal to 3 squared, multiplied by our height of our 3D shape, which is 10 centimeters. When we calculate all of that out, we get 282.74. We are working in centimeters, so the answer would be in cubic centimeters, remembering that this says to 2 decimal places. All right, our second one, this time we still have a cylinder, so we know that the cross-section will still be a circle. This time, however, we need to think about some information. To do our area of a circle rule, we need to have a radius. What we've been given here is a diameter. If the diameter is 1.8 meters, then our radius is going to be 1.8 divided by 2, which is going to give us 0.9 meters. And if we flip that cylinder over and sat it on its cross-section, then our capital H for 3D height would be this 0.3 meters right here. So we can find volume with that same formula. Area of the base multiplied by the height, or area of the cross-section, my apologies. And we know that the cross-section is a circle, so pi r squared multiplied by height. Pi times our radius, which we found was 0.9 squared, multiplied by 0.3. If we calculate that out, here is one I prepared earlier, 0.76, and we are working in meters, so therefore it is cubic meters.